Okay, udah deh ya. Oke, aku mulai. Okay, good afternoon, everyone. I'd like to start this tambahan ini, this extra class by discussing 2020's midterm exam. I've already sent you the exam by WhatsApp, and now I will do it for you. But before I do it, has anyone tried doing this yet? Yan kaya nyoba. Langsung aja dimulai ya. Vectors A and B are the diagonals of this cube with lengths P. So we know that A is going towards from D to G. This is A. And B, that is E to E. So this is B. And R is D to F. So now let's take a look at the G point, the XYZ. The XYZ for G is assuming this is P, this is P, and this is P. So that would make it, it would have P and P0. And for point E, E would have 0 on the X, P on the Y, and P on the Z, while point F is P, P, P. Now they say at point A, I mean the question at point A, they're asking for a C component, where the component C is equal to A cross B. Now, if you guys remember how to do cross products, let's make it. So now the top is going to be, this is going to be A, it's going to be B. So this is P, P0, 0, 0. Now, taking the I component, we have oh, I'm sorry, this is 0. P0, oh, and this is P. P0, P minus the J component. which is going to be P 0, 0, P plus the K component, which is gonna, sorry, which is gonna be P 0, P. So this is equal to P squared I minus P squared J plus P squared K. So this is the answer for point A. Now let's take a look at point C. Question B. Theta between R and A. So from this, we know that R is equal to D from F to D, from D to F, which is equal to this. And A is F. Now there are two ways to do this. You can take the cross product of R and A, but the easiest way to do it would be taking the dot product of R and A. R and A is going, this is going to equal the magnitude of R times the magnitude of A cosine theta. Now first, what you have to do is take the dot product of R and A. So R is going to be P, P, P dot with P, P 0. Now that is going to equal E squared plus P squared so 2P squared is equal to, but now we take the magnitude of R, which is P squared plus P squared plus P squared. Multiply that by the magnitude of A, P squared plus P squared. So what you get is uh, the P goes out, and then 3 times 2, so this P over 6. This is wait. P times, this is going to be cos theta is equal to 2P squared over, the P goes out, P times P squared over 6. 2 over square root of 6. So this is equal to arcus cos 2 over. Now this is obtained by calculator. Without calculator, it's impossible. This is the answer to question D. Ada yang resign ya? Sorry, virus Nabila.
Mas, aku mau nanya itu yang dari awal kan ada PP sama zero itu dari mana ya, Mas?
Yang mana, yang mana?
Yang di awal yang faktor A
Oh,
terus ada PP sama
ini. Kalau dilihat dari
zeronya dari
soal,
mana?
kan dikasih tahu A itu dari G ke D ya. I mean, sorry, dari D ke D, D ke G. Ini kan gini ya. Tuh nggak? Ini scroll ke atas dikit ya. Aku coret di atas. Coba kalian whiteboard tadi scroll ke atas. Kelihatan nggak tulisan aku yang baru dari D ke G?
Ya, Mas, kelihatan.
Ini kan berarti nanti itu sama aja dengan misal, sorry, bukan gitu. Nah, di sini kan kita tahu kan G-nya kan. G itu kan di ujung atas kanan ya. Ujung atas kanan itu kan dia punya nilai X, dia punya nilai Y, tapi Z-nya 0. Betul nggak? Kalau lihat dari gambar.
Iya, Mas.
Nah, berarti kan G-nya itu P, P 0. Sedangkan si D-nya itu kan origin kan. 0, 0, 0. Makanya kita bisa dapat kayak gini. Sama dengan yang lain juga.
Oh, oke, Mas. Makasih, Mas.
Lagi? Kalau nggak ada, uh, number 2 ya. Coba kalian scroll lagi ke bawah. Ntar, number 2 tuh soalnya udah aku post di bawah nomor 2 soalnya. Sebuah bola dilemparkan dari lantai ke-8 menara sains. Yang ketinggiannya 30 meter dengan kecepatan awal 10 meter per second. Dan membentuk sudut 45 derajat terhadap vertikal ke atas. Oke, start with 2A. Sketsa lintasan partikel. Itu pasti parabola ya. Parabola, tapi kita meninjaunya itu dia apa namanya? Uh, dari sebuah ketinggian. So let's say we have this. This is 30 meters. And it moves like this. And it says that it makes a 45 degrees towards the vertical. So ini 45 derajat. Tapi di sini juga, sorry, di sini juga 45 derajat berarti. That's point A. Oh, jangan lupa ada V. V-nya itu V0. 10, 10 meter per second ya. 10 meter per second. P0-nya 10 meter per sekon. Nah, point B itu berapa waktu yang diperlukan untuk mencapai tanah? Oke, langsung aja. Kalau kalian masih ingat rumus GLDB. Kita tahu Y akhirnya 0 dengan Y awalnya itu 30 meter. Then you add the initial velocity towards the Y direction. You 10 plus, sorry, minus, take the G as 10, so this is immediately 5t squared. Now, as you can see, ini ada T-nya. As you can see, it forms a quadratic formula. Kita kaliin satu aja kali ya. 5t squared minus 5 akar 2t minus 30. Nah, ini divided again by 6. So, by 5, I mean, t squared minus the square root of 2 times t minus 6 is equal to 0. Nah, ini bisa kalian pakai rumus ABC. Wait ya, ini daripada aku plugin satu-satu kan lama ya, aku pakai photomat aja ya. So, x1 is equal to minus 1.84 seconds. Ini tidak memenuhi. Tidak memenuhi because time. Oh, ini T1 deh. T1, 2. 1x1, 2 kalau dikasih ini. T1, 2, T1, terus T2-nya 3.25 seconds. Nah, ini yang kita gunakan untuk perhitungan. Nah, ini kan ada jawaban yang poin B. Sekarang poin C. Hitunglah jarak horizontal yang dicapai bola dihitung dari lantai ke-8 menara. Ya udah, just plug it into the normal formula that you know. S sama final x by t. You know that the initial velocity is 10 and then the sine of 45. So projected to the to the x-axis, multiplied by the time, which is 3.25 seconds. So this is going to equal times 3.25, 22.98 seconds. Sorry, meters. That is number 2. Hey, any questions before I move on? Okay, now everyone take a look at take a look at number 3. There is 2 blocks A and B, where block A is 4 kilograms and block B is 2 kilograms. The static coefficient of block B and the surface is 0.5, and the inclined plane does not have friction. The angle of the inclined plane is 30 degrees, and the what's it called? Katrola tidak bermassa. Now we are asked to find A, the tension, and B, the acceleration. Okay. Since there is no friction on A, this should be quite a straightforward question. Just draw the diagram. This is berat, reject it. And you have the normal force. Then we do it for this one as well. So it's T1, T2. For this one, there is a friction. There's a normal force. And there is also berat. Okay, so let's take a look at system A. Okay, sorry. It's MA. M8A. Now, if we take a look at the x-axis, what we get is keep in mind the negative sign is up to you. Yeah. It doesn't always have to be like this. It doesn't always have to have plus to the right. Sometimes people use plus to the movement. So it's really up to you, as long as you're consistent with it throughout doing the equations. Now let's take a look at the other system. Now on the x-axis here, there's going to be quite a lot. So you're going to have T2 to the left. You're going to subtract that by friction. And that is going to equal this. Now we have to also take a look at the Fy. It's going to be 0 because there's no movement towards the y-axis. So it's going to be straightforward. The normal force is going to be equal to W, where this is just simply the mass of B times gravity. Now from the question, we know that the mass of B is 2 kilograms. Yeah, 2 kilograms? It's 2 kilograms, and yes, we take the gravity as 10, so it's equal to 20 newtons. So from that, we can get friction. We know that the static coefficient, the kinetic coefficient is 0.5 times 20, so it's equal to 10 newtons. Now from this, we will be able to gain the relation the tension on system 1 will be equal to the tension on system 2 because they are the same rope. And before we know that this W x minus T1 is equal to MA. So we can solve it for T1. This is 1. And then for number 2, for system 2, we also gained T2 minus friction is equal to the mass of B times acceleration. Solve it for T2. And what you get is the mass of B times acceleration added with the friction. So now you can just plug in the values of T1 is equal to T2. So what you get is when you add this with friction. And now what you want to do is isolate each component that has an A variable in it, acceleration, because it's asking for acceleration. So you want to isolate anything that has acceleration in it. So what's going to happen is you're going to have the mass of B times A added with the mass of A times A. It's going to equal friction plus friction minus this. Now what you're going to do is take out the A. Then you move MB plus MA to the right side of the equation, where you get it as this. Now all you have to do is plug in the values. Now what you can do is just take this, since we already know friction, just leave it at that. And then you subtract this by mass times gravity, sine of theta. By the way, someone's calling me. Okay, I'm back. Sorry. I just realized I made a mistake. This is plus. This is negative. This is plus. Negative. So this is plus and this is negative. Now all you have to do is plug in the values. You have the friction is minus, tadi berapa friction na? Friction is 10 plus, oh this is MA. MA itu tadi berapa ya? 4 multiply by 10 multiply by sine 30. And this is simply 4 plus 2, 6. This is 2, 10 minus, okay, minus 10 minus 10 plus 20, so it's 5/3. This is the answer to point A. A, the acceleration. Now for point B. Point B is asking for tension. Since we already know that tension 1 is equal to tension 2, we know that T1 is simply equal to WAX minus mass of A times acceleration. We already know the acceleration. And for this, all you have to do is plug in the values. This is 4, this is 10, this is sine 30, 4 times 5/3. And what you're gonna get is 40/3 newtons. And yeah, so what if it's up? 20 minus 20. 20 minus 20/3. 60/3 minus 20/3. Yes, 40/3. This is the answer to point B. Okay, next. Number 4. Okay, number 4, we just went over this in class. For A, kecepatan balok ketika tepat mengenai ujung tugas. Oh wait, let me review the question first. A block with a mass of 5 kilograms is released with no initial velocity from a height of 5 meters with no friction. At the end of the path, there is a spring with a constant of 400 newtons per meters. When the block hits the edge of the spring, the block gets a frictional force with a kinetic coefficient of 0.2 and compresses the spring as much as x. For A, find the velocity of the block right before it hits, right when it hits the end of the spring. Okay, kalau kalian masih ingat from today's class, we have what is called kekekalan energi. So the energy of a system is constant. We know that the potential energy is mgh. Add that with the kinetic energy, it's going to be equal to, mgh plus the kinetic energy. Oh, this is V2, H2, V1, H1. So at condition 1, it's gonna have 0 kinetic energy, so it's just gonna be mgh. It's gonna have 0 kinetic energy because first and foremost, it has no initial speed, so it's just gonna be mgh. Now at the second condition, right when it hits the spring, it's gonna have maximum kinetic energy, so therefore it will have 0 potential energy. Because at that point, the height of the block will be 0 anyway. So it's gonna be equal to half of m times v2 squared. So we know that v2 squared is going to be equal to 2 mgh. Then you cancel out the m's. V2 is going to be equal to square root of 2 times gravity times h. So we know all of those values. Oh, this is h1. Don't forget this is h1. 2 times 10 times 5. The square root of 2 times 10 times 5. That is going to be equal to square root of 100. So V2 is going to be 10 meters per second. Any questions? Okay. Now for point B, it's asking for the compression of X. Now in point B, there's going to be energy conversion. The kinetic energy is going to be converted into spring energy. And those values are going to be equal. So the kinetic energy it's gonna be apa ya pegawai enaknya? E spring aja, ES. So this is going to equal this. Now we know K, which is the constant. We also know the mass, and we also know V. Let's just take away this. After that, we can solve it for X. X squared is going to be equal mv squared over K. So X is going to be equal to V squared root of m over K. Now we know that V is 10. The mass, tadi massnya itu 5. And the K is berapa tadi? 400. Okay, let me use a calculator for that. X is going to be equal to 1.12 meters. Okay, now point C, usaha oleh gaya gesek. The work caused by friction. So all you have to do is take work is equal to F times S, the displacement, or X in this case. So now we have F as friction. Multiply that by X. Now what we're gonna have to do is, let's draw this. Since it's moving towards the spring, the friction is going to be this way. But we will only be taking a look at the y-axis, which is equal to 0. We have the normal force here. So this is going to be equal to this. The mass times gravity. The mass is 5 times 10. It's equal to 50 newtons. So now, take a look at the friction. The coefficient is 0.2. 0.2 is 1/5 times 50. So that should be equal to 10. So now the work is just 10 times the displacement, which is 1.12. Which is going to be equal to 11.2 joules. Any questions? Is there a way for me to export this, like, so you guys can what's it called? Save it? Oh, I can actually. Wait, let me send it to the group. Okay. Before I end today's session, are there any questions? Because I will only be going over this packet of exams.
Mas,
Yes.
is this the particular equation that might be held on the ETS tomorrow? I mean, if you can assume that. For the previous ETS, this is a current equation that always come out.
For questions like number 3, there's really no specific equation that you can use. But for example, for number 4, point A, this equation is often used.
Okay.
This one. That's often used. And the case might be different. It might not always end up with this formula. But you will always use this relation. This is very often.
Okay.
What else? What else? And of course, for number 2, since every year parabolic motion always comes out, so you should not only remember this one, but you should also memorize the 3 other ones.
Okay.
What else? What else? I mean, for number 1, in my opinion, number 1, there's really not much for you to memorize, because if you know the pattern for cross product, you don't really have to memorize the formula. Like if you're looking for the I component, just cover up I, just cover it for a second, and then you have this, right? Put it here. Okay, that's also the same for the J component, just cover it up. But you have to remember that this is always negative. And then you put it here. And then what you do basically after that is just multiply this and this. So let's say you have A, B, C, D. It's sorry. AD minus BC. Scroll up, guys. Scroll up. I'm writing at the top. I'm thinking about something else. Papalagia. Oh, sama. Yeah, paling ini sih. Go to the bottom. If you guys aren't following my screen, go to the bottom. You have to be able to do questions like this. You have to be able to do the ones like this. These come out a lot. Well, not a lot, but sometimes they come out. Just be prepared for this. This isn't really something that's hard. All you have to do is, for example, on F1, project it to the x-axis and the y-axis, and then do that for F2 as well. Project F2 to the x and y-axis, and then you just have to find the resultant of f, which is just equal to fx squared plus fy squared. Understand? This isn't really too hard. Most of the time when it comes out, everyone is able to do it.
Okay, thank you, Mas.
Anything else? Anyone have any other questions? Oh, close it. Okay, if there aren't any questions, well, if you have any questions that you want to ask suddenly, that you don't know if you only thought about the question later on, please do ask in the group or text me. It's up to you. I'll try to reply as fast as I can. Thank you for tonight's meeting. I apologize if there were any mistakes. And good luck on your midterm. I'll see you on Wednesday at 9, I think. 9, yeah.
Yeah, thank
Okay.
you, Mas.
Good luck on your
Yeah.
midterms.
So much, Mas.
Thank you, Mas.
Jangan lupa
Very
di-share
much.
recordingnya ya,
So much,
biar
Mister.
teman-teman yang nggak datang bisa nonton.
Siap.
Thank you, Bang.
Thank you, Mas.
Aku end ya.
Iya, Mas. Makasih banyak, Mas.
Thank you, Mas.